All right, so this was the last slide that we saw during our last lecture, and we are going to continue with this slide. And if we have time, which I think we will, we're going to take a look at some of the calculations that have to do with the pipe bending, making offsets. All right, so portable access ladder with scaffolds. This is basically a scaffold. Now, the ladders must be secured to prevent the displacement. So basically, all the rules that apply to using of the ladders apply to using the scaffolds. And one thing that you really have to make sure is obviously is that we need to make sure that the ladder that we're going to put against the scaffold, it is not going to tip the scaffold so it doesn't fall down. Right? So ladders must be secure to prevent displacement. Right? Secure from the top, secure from the bottom. Extend at least 3 feet above the landing surface to provide a handhold. So that's the same as the rules that we studied with the ladder. Whenever you have the landing surface, so here is your starting point at the bottom, and then just get a different. Do that. Yes, there we go. We can see the pointer. Now extend 3 feet above the landing surface. So here is the starting point. Here is your landing surface because you're going from here to there. So that is going to become your landing surface. We need to extend the extension ladder or a straight ladder 3 feet above the landing surface for the comfort of stepping in and off the landing surface. All right. Now, attachable access ladders. Yes, some of the scaffolds will be equipped with the attachable ladders and they look like this. Again, what I'm saying is that whenever a scaffold like this is going to be set up, it will be provided and set up by the company who does that. I'm raising the awareness for you to pay attention to some things that might have gone wrong or things might have been displaced or otherwise disturbed during the work process. So you need to know what to look for, or the risks and the hazards, or the hazards and the risks thereof. When it comes to working on scaffolds, just because somebody set it up for you and then when things are being signed off, doesn't mean that things are going to continue that way. You always have to be on the watch. It is your safety that is at stake, and safety has to do with your well-being, and sometimes for the rest of your life. All right. Now, so yes, there are sometimes they're available, those attachable access ladders. They are being used to well, climb on and off the platforms of the scaffolds. Again, do not use anything else but whatever the equipment is provided for us to access the scaffolds area. All right, do not climb the cross braces. Okay. All right, what else can you see here with scaffolds? To get on and off the scaffolds, you can also have scaffold stairway. And I'm pretty sure that now when you drive around and you see some construction sites with scaffolds placed around them, just take a look and see if you can identify some of the elements. And this is the scaffold stairway, and this is probably the best way to end. Basically just a bunch of steps that you climb and railings that go along. And I would say this is probably the most comfortable way of getting on and off the scaffolds. All right. Falling objects protection. This is also something that we have to consider. Anyone working on or around the scaffold must wear a hard hat. Well, that goes pretty much without saying that with any of this area that is considered a construction site, yes, we have to wear hard hats and otherwise protective equipment. But we're talking about falling objects, and well, it's not, you're not going, we will never get 100% protection, but we must do everything that is required to protect ourselves the best that we can. Workers on or below scaffold must be protected from falling objects by, right? So aside from us wearing the hard hats, there are some other means of protecting us from falling objects. So we use toe boards, mesh, screens, or equivalent measures. All right. So let's see. This would be something that's called a toe board, right? Just like your toes. So this is a toe board. So this is supposed to give us some little extra protection on, well, that have to do with the falling objects rolling off the platforms and whatnot. So this is one way of doing it. Mesh, here's a mesh. All right, that's even better than the toe board because, well, it gives you a little bit more protection here. What else do we have? What type of scaffolds do you use? Here is a picture that I inherited from the previous years. Well, can you identify the parts? Is there a stairway there? No. Is there a ladder? No. Is there a toe board? No. Is there a mesh? No. Do the platforms extend 6 inches at least? Yes. Well, that's one thing that's correct about that, but it's about it. All right. Do they have cleats? No, I don't see any cleats happening here. Nope. All right. What else can we do? Is there a ladder? No, there's no ladder. And there is no tie-off protection. There is no safety harness provided for the workers, but they're wearing hard hats. That's good. Okay. All right. Types of scaffolds that we have covered would be, or we're going to be talking about, well, fabricated scaffold frame. So this basically prefabricated things that is being delivered and assembled for us, right? Then we'll take a look at the pump jack scaffold, ladder jack scaffold, trestle and horse scaffolds, roof bracket scaffold, top plate, area lifts. So you can tell that there's more than one way of us getting to the height of our work. One is the ladders that we have studied. The other one is right now that we're studying we're taking a look at the scaffolds. Well, there's some other ones. There are lifts, there are scissor lifts, there are boom lifts. One thing I'm going to mention, we need 2 tickets presently in order to be able to use the ladder or scaffold or any kind of means of getting ourselves to the height of the work that we have to perform. One is called working on heights ticket, and the other one is the lift ticket. Right? So without working on heights, it used to be called fall arrest, and fall arrest, basically it's a fall prevention. It's not how to fall, it's how to prevent the fall. And yes, there's a little bit of training. Part of the training is once you fall is, how to behave a little bit. We're not going to go over that. Um, but in order for you to use a ladder or anything, on the construction site, you have to be in the possession of those tickets. Where do you get those tickets? A good way to search for those would be the rental companies, because many equipment rental companies, the construction equipment rental companies, they do provide training. It costs a little bit of money, but it costs way more money if you get cut on the construction side without those tickets. Right? It's a piece of plastic that is saying that yes, this person has participated in the training, and here is the certification, name of the instructor, and whatnot. It takes about 1 day each, or maybe sometimes a few hours here, a few hours there. So maybe sometimes some companies in 1 day will do two: fall arrest and not fall arrest, working on heights, and the lift ticket. The working on heights is basically if you need to step on a ladder or scaffold, and the lift ticket is if you use any of the mechanical devices such as scissor lift or a boom lift. If you don't have those, do not get yourself on any kind of height using anything on a construction site. All right, some of the examples, because yes, I said trestle horse, scaffold, and some other ways. So here is an example of a trestle and horse. Okay, just so you know what it looks like, just so you don't just look at the text and say, okay, well, that's what the trestle and horse scaffold looks like. And then when it comes to, well, sometimes on the siding, on the side of the walls or the buildings, you are going to use, or you're going to come across something that's called the pump jack. It's basically a platform on another platform, right? And you use the foot pedal to go up or down, to move yourself up or down. So that's what the pump jack looks like. All right, ladder jack. It's almost like a pump jack, except there is no foot pedal to pump up and down. This is what a ladder jack looks like. It's a mechanical structure that you're going to basically set up so you can work on heights this way here. So here's one example of using the ladder jack. All right, and here's another example of using the ladder jack. One thing I'm going to point out when looking at this picture right here, the tie off is not the best in this case here. Look what is going, and then you're going to get that training, but there's just, this thing just strikes me right at the beginning when I look at this picture here, and I decided to leave that because I want to bring your attention to that. Look at where this person is tied off. Here's a lanyard, here's a harness. The harness could be approved or not, I don't know, right? Because I can see the details of the harness here. Wherever that person is tied off, what is going to happen if this person falls off this platform? Well, he's got a bit of traveling to do, which would be the length of the lanyard. And when it comes to the gravity of our planet, by the time the lanyard starts working, this person might experience quite a bit of a mechanical shock to his body. What you're supposed to be tying off is tying off a little bit higher, and there's a certain height you should be tying off, just to make common sense, one thing, and the other one is to be legal, right? So you're not creating yourself a situation that I'm not sure which would be worse: falling down onto the ground or being stopped by the lanyard. And when it comes to harnesses, they also have to be done certain ways, and they have to be the strapping has to be also done certain ways as well. Right. So yeah, this I would not like to be that person if he slips and falls, because he's just going to travel and all of a sudden he's going to be stopped. You can get your spine broken that way. All right, fabricated frame. This is what a fabricated frame scaffold looks like. It's not something that you have to construct yourself. Not something that you have to construct yourself. This is not a prefabricated frame. And no, it is not a correct way of doing things. This is a fabricated frame with a stairway, and all the pieces fit together like Lego blocks. and things go together, and probably there's going to be some manual. And this kind of scaffold is supposed to be set up by a competent person. If you have the training on how to do it, yes, by all means. But usually these kind of structures are being set up by the companies who provide, or rental companies, the scaffolds. You can see that there's some mud seals, there are cross braces right here to keep the structure in place. You can see the platforms sticking out far enough. Do I see any cleats? I don't see any cleats, but there could be those, there could be the hooks that are provided to keep things in place, so that probably will be fine. This is a correct way of setting things up. All right. Now, guardrails. Important to have guardrails. These will be the guardrails, so you can walk on the platform and not fall off. No, makes sense, right? Cross bracing, important. What are cross braces? Cross braces are these structures right here, and there's a pivot right there. There's a joint right here. So after those things are being disassembled, they basically fold onto one. If there's a cross brace, if you disassemble that, it just falls onto one kind of a piece, and can be transported. Right. So these are the cross braces, and again, the purpose of those is to keep the structure, to keep the integrity of the structure. They are not to be used to, you should not be climbing those. I've seen people climbing those to get to the platforms. No, do not climb those. They are not designed for that. If something happens, you're not covered, probably. All right. Using uplift pins. There's pins, there's well, it's an example of prefabricated frame. Once one piece goes onto the other piece, there is an opening that you can just push the cross uplift pin, and make sure that those pieces do not separate under any sort of undesired movement. It's an extra safety feature, right? Okay, scaffolds within with height of with a height to base width ratio. Okay, height to base width ratio. So here's a height, here's a base width. 4:1, 4:1. Must be restrained from tipping by guying, tying, bracing, or equivalent means. Basically, this thing has to be properly fastened. So it could be it could be tie off to the building. You could use the guy, you could use guying, or you can tie things to whatever you need to tie off. Bracing, use bracing here, and whatever other equivalent means that are necessary for that. If you're not sure, then ask. If you're not sure and there's nobody to ask, well, you know what, maybe you shouldn't be doing that, because well, your life could be at stake, or the quality of your life could be at stake. Or what is guying? Because it's kind of unusual word. All right, if you see some of those towers, communication towers, this would be the guy wires. That's an example of that. So there will be some guy wires going on the ground, onto the ground. All right. Bracing support. See, here's bracing. There's cross bracing, and there's bracing. Here's bracing. Right. Remember the center of gravity. By bracing, you are extending the area of the base. So if there's a center of gravity, you can go further with the center of gravity. So this is preventing this whole structure from tipping. And it gives extra protection than just having the base. Because remember the safety of the center of gravity. If the center of gravity of the whole structure goes beyond the base, then the structure tips. All right, mobile scaffolds. when it comes to safety of mobile scaffolds. Do not move those mobile scaffolds while occupied unless specifically designed. Whatever this, if it's designed to be moved, yes, but mobile scaffolds, you should get off of them, move them, and then climb back again. Right? Before moving, inspect for pits, holes, or obstructions on the floor. Right? As I always say, there's a difference between the equipment that you purchase at your local hardware store or whatever department store. Those devices or whatever you buy are designed for a regular consumer use with all the safety features considered in the design and manufacturing of those devices. When it comes to construction, you are working in a rough environment, and the safety features you have to take care of yourself. Well, that's why you're getting the training on that, right? That's why you go to school for doing things. So before moving, inspect the floor for pits, well, any kind of obstructions that might affect the structural integrity. That's my favorite saying here of whatever it is that you're moving. Push the base or near the bottom when moving. Obviously, the lower you position yourself to push that, or the lower you grab this thing to push that, the less chance of a tipping you're going to get, right? Do I need to explain that? Grab it here, you move it. Grab it here, you tip it. Yep. Caster wheels, casters must be locked to prevent movement. Well, you're going to have to open them to when you want to move the scaffold, but once you're working on them, the caster wheels have to be locked, and those are the foot brakes. You step on that and it locks the wheel in place so it's not moving. When you push this brake down, make sure that this thing is not moving. Kind of grab the frame, move it around, see if the wheel is locked. Always verify things. Roof, brackets, scaffolds. This is not something that, as far as electrical work, you're not going to get a lot of exposure to that. But since we're talking about the scaffolds and platforms, might as well mention that. So let's see what this one says. Scaffold brackets must be constructed to form a pitch of a roof to create a level work surface. So this, whatever the angle of the roof is, that platform, the scaffold bracket here, must be accommodating the pitch of the roof. What's the pitch? It's the angle the roof is on. Okay. Because you need to have a leveled surface right here. When brackets cannot be nailed into place, 3/4 inch manila rope should be, so basically it's a rope, it's a brown or grayish kind of a rope, should be used to secure things in place. And we must use personal fall arrest system. What's a fall arrest system? It's a fall prevention system. Like this here, but it has to be installed and used correctly. Personal fall arrest system. It's a harness with a lanyard tied off in a way that it makes sense. This here again, I repeat, this is not a safe way of doing things. Whenever you use people working on the scissor lifts or boom lifts, for sure you're going to have those harnesses. If somebody walks by, if safety inspector walks by and sees you without those harnesses, you might get into trouble. And always check, because those laws change what you actually need to have as personal fall arrest system. And also when you get the training, which is usually provided by that's a good place to start. Or, you know, if you go to any of the supply stores, like for example, electrical supply stores that we have all around our town and everywhere else. If you ask, where can I get working on heights ticket or lift ticket, they also might be able to provide. It's not their job, but usually those guys, those people will know where to find that kind of training. But the best way to start is to look at some rental companies, and most of them actually do provide training on that. And again, I'm going to repeat that. Do not use a ladder or any kind of lifting device on the construction site unless you have the right to do that. Even a 6-foot step ladder, you need to have the right to do that. It wasn't like that before. It is now, and the penalties are more severe than you would like. Right, so this is the last slide of this of the scaffold that we have covered. Now we're going to just continue with some of the pipe bending, calculating the offset. I was asked to go over some of that in some of the repetitive details. So let's take a look at some of that stuff here. All right. Now, just going to open up another. All right. Google. All right. Pipe bending guide. Let's see what we have here. Claim or ideal. Here's the claim. Let's see what they have for offsets. We looked at the ideal pipe bender guide. Let's see the table for the offsets. What do they have here? 3 point saddle. No, there's gotta be some offset formula table. All right. Angle of the bend, 10 degrees, 22.5, multiplier, and shrink per inch. I'm just trying to find, excuse me, let me just, do I have one here? I think I do. Yes, I do. There we go. Here is a Klein pipe bender. Let me just stop share for a second. Let's see where there's a table. Yes, there's a table right here. Okay, on the sticker. We look at the ideal one, which is the blue handle, and here is an example of a Klein. What else? What else can we just see here? This one says it is 1/2-inch EMT only. Right? We still in our class, in our lab, we also have the 3/4-inch EMT, which is going to be a little bit wider shoe here, because the 3/4 is thicker in diameter than 1/2-inch. Of course, 3/4 inch is thicker than. So for 1/2-inch pipe, use 1/2-inch pipe bender. 3/4 inch, we use 3/4-inch pipe bender, and so on. Otherwise, you're going to have you're going to deform the pipe when they try to bend. Right. So it says 1/2-inch EMT. What else does it say here? And we already have done some of that in our class. Stubs, 5-inch to, it's stubs. It says stubs 5 inches to the arrow. Where's the arrow? Here's the arrow. If you align If you align the pipe, if you make a mark and align that with the arrow right here, where is that? Here. And if you do a 90-degree bend, that mark that you made is going to be raised 5 inches from the surface. What does that mean? Let's do some screen sharing again. It says 5 inches to stab. We got the pencil. All right, so if you have a pipe and if you make a mark right here, wherever you make the mark, and if you bend that pipe, if you align that mark with the arrow, you bend that pipe 90 degrees, that mark is going to find itself 5 inches from this surface right here. Okay? So that's what it means. Can you guys see me sharing the screen? I don't think you can. Yeah, I think we do now. Hey. Can you? Oh, I can't even see the chat anymore. Share screen. This one. There we go. Now you can see the screen sharing. Hey. All right, let's do it again. So on this pipe band there, it says 5 inches to is stabs 5 inches to the arrow. What's a stab? Stab is a 90-degree bend. All right, let me do it again. Can you see the screen sharing right now? I'm just doing some random lines here on the screen. Can you see that? Good. All right. Beauty of technology. All right. So if we have a pipe and wherever on that pipe we make a mark and we align that mark with the arrow of the pipe bender right here, the arrow. And if we do a 90-degree bend like that, that mark is going to be 5 inches above this surface right here. This distance is going to be 5 inches. Okay, that's what that means. Now, we're going to take a look at some of the offset bending. What does the table say on this here? Let's see what the table says on that little sticker. If you want to clear, oh, can we? All right, so the table says if you want to clear 4 inches, I wonder if we can see it here. If you want to clear 4 inches here, there we go. Can we see it? I guess we can't. Okay, so here it says the clearance 4 inches. And then let's say we're going to use the angle of 30 degrees. It says we need to make 8 inches between the bending points, and the pipe is going to shrink a whole 1 inch. All right. So the table on the sticker here shows the table shows 4 inches. Okay, and then it shows 8 inches. All right, and it says 30 degrees. I don't have the degrees here. Yeah. "30 degrees." All right, we keep going with that. And then it shows 1 inch. So that's basically on the table, part of the table. Yeah. It's just a snapshot of the table, one of the rows. All right, let's take a look at what does this mean here on the sticker. That's an offset guide. So here we have a pipe, and we're going to make an offset. So the height of the offset, whatever that thing is here, the height of that is 4 inches. Height here. And if we want to use the angle of 30 degrees, which is this angle right here, on there, angle theta, that's the angle right here. Then the distance between those two bending points is 8 inches right here. And the pipe is going to shrink 1 inch, which means if it was a straight piece of pipe, it would extend that much. And after the bend, of course, that thing is going to retract. Share the screen. Oh my God. It's not even Monday, it's Friday. Can you see my screen here? Good. All right. So the table says on the pipe bender, it says 4 inches, 8 inches, 30 degrees, 1 inch. Clearing 4 inches height, doing an offset. The table on the sticker says we have to make the bending points 8 inches apart, and the whole pipe is going to shrink 1 inch, which means if it was a straight pipe, after doing the bend, because it's going to retract when you bend it, it's going to, this distance right here, from here to here, that distance, it's going to be 1 inch less altogether. How do we calculate that? Let's see the formulas. Let's get to that point. All right. So first we have to find the multiplier. All right. What's the multiplier? A multiplier is the cosecant of the angle. What's a cosecant? It's 1 over the sine. What would be the sine of 30 degrees? Calculator. 30 degrees, and this is the way this one works, trigonometry, sine, it's 0.5. We have to flip it around, which is 1 over 2, and flip it around is going to be 2 over 1, so it's going to be 2. Let's see. Do the flippage thingy. Oh, it's 2, so the multiplier is 2. What am I doing wrong this time? I'm not able to do anything because something is not happening. I haven't done something. Yeah, okay. All right, so the multiplier is 2. Okay. How do we get the distance between those two marks? We multiply the multiplier times the offset, which is the height of the offset, which is times 4. That gives us 8, right? Which is this part right here. So that gives us the 8 inches between the two bends. If we bend that 30 degrees and bend the other, well, first bend that 30 degrees, then flip it around and bend it the other way 30 degrees, that travel here, this travel is going to be, if we travel 8 inches, we're going to go 4 inches high. If we go further, we're going to go higher, right? But we want to get 4 inches. There you go. 8 inches is the distance between the two bend points. And then it says that the whole pipe is going to shrink 1 inch. How do we get that? Well, the formula for that, for the shrink, now, per shrink per unit of rise. Shrink per rise is sine over the theta divided by 1 plus cosine of that angle. All right. So what do we have? Sine of 30. Remember what we had? Sine of 30 is 0.5. 30 degrees sine 0.5. Okay. So it goes 0.5 divided by 1 plus cosine. What's a cosine of 30 degrees? 30 degrees trigonometry. Cosine is 2, right? Again, 30 degrees cosine. Sorry, it's not. I see. Yeah, I did something wrong. Okay, cosine of 30 degrees. 30 degrees trigonometry. Cosine is 0.866, blah, 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 right? But we have to add 1 to it, so we're going to go plus 1. All right, so we get 1.8666, whatever, 660, blah, blah, blah. Okay. So let's put that in the memory of the calculator right here, and these are going to light up. We have it in the memory, okay? Because we have to do 0.5 over that number. So we're going to clear the board, but we still have the memory there. So 0.5 divided by memory recall here equals, it gives us 0.267 blah 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 inches. That's 0.267 per height of rise. So in order for us to find out the whole shrink, so for every inch of rise, this thing is going to shrink almost a quarter inch or a quarter of an inch approximately, right? But if we want to know how much the total shrink is going to be when we do this type of a bend, we have to multiply it by the rise. So that thing times 4. And that gives us 1.07 of an inch. So there you go. Here's a sticker that says on the table. There's a table that's on the sticker on this Klein pipe bender. To clear 4 inches obstacle, the distance between the two bending points is 8 inches if you use 30 degrees, and the whole thing is going to shrink 1 inch. So this is a bit of a quick reference here. Now I'm going to stop screen sharing for the last time here. All right, so this sticker says, let's say if we want to clear 5 inches, and on this sticker it says the distance between the bends says 7 inches if you use 45 degrees. Also, was that okay? 2 inches. The distance is 5 1/4. If you use 10 degrees. Right, now, where do we get our box offset? When we do our box offset, remember when during the class we are telling us we are telling you to make 2 marks. Again, okay. Turn it off, turn it off, turn it off. Okay. When we do the box offset, that's what we're going to do. Here's the box. We're going to do 2 box offsets. Here's another box. Here's a knockout. Here's a knockout with a connector, and we're going to do the pipe. So here's an offset, continue, and we're going to make another offset. So basically what we're doing this with the pipe. What's the height that we have to overcome is 3/8 of an inch, because that's on the utility box. That's the height that we need to come over, right? And then the angle that we do here is 10 degrees. Right? So we got the angle of 10 degrees, and we need to make ourselves go 3/8 of an inch high. All right. So what's the multiplier? Multiplier equals 1 over sine of the angle. So 10 degrees trigonometry sine. It's 0.17. Flip it around to get a cosecant, right? So flip it around, and it's 5.7, 5.76. 5.76. What's the distance between the 2 marks? All right, or the travel, which is the distance between 2. It is the multiplier times the rise. What's the rise? 3/8 of an inch. It's the multiplier, which would be 5.76 times 3/8. Right? What's 3/8? Let's get the 5.76 times, what's the 3/8? Just for kicks. 3 divided by 8 equals 0.375 times 0.375. All right, 3/8. Oops. 3 divided by 8. There you go. Hey, 3 divided by 8 equals 0.375 times 5.76 times 5.76 equals 2/16, 2.16 of an inch. So the closest thing that we have on the thing, just to round things off, that's why we're making the mark between the distance between those two bands, 2.25 inch. Okay. So if we want to do the box offset for that, we choose that distance because over here we decide how long that is going to be, and 2.5 inches is okay. So wherever you make the first mark, then the second mark, 2.116, right? But 2.25 is good. So that's what we're going to do. That's where we get these numbers from. Right? Okay. Are you guys still around here? Let me just see. Do we have the participants? Yes, we have 8 people here still. Good. All right. This is the end of today's class. And happy Friday to everyone. Enjoy the weekend, and I'll see you on Monday. Thank you, guys. Bye-bye.